So the next topic which we are studying is screening effect, or this effect you can call it as shielding effect also. Okay. Now let us try to understand what is the meaning of this screening effect or shielding effect. Clear? Seema. So consider this is the nucleus where protons are present according to the atomic number, and around this shells are present. So I am drawing them in the form of orbits. So actually shells are present. Are you able to understand? Now if you take the electrons which are present in a particular shell, you can take any shell. It is not that we have to take only outermost shell. You can take any shell. Second shell, third, fourth, five, any shell you can take. For example, I am taking the outermost shell, or let us take this middle shell. So here there is an electron. Clear now? Now this electron will be experiencing two forces. It will be experiencing force of attraction also. It will be experiencing force of repulsion also. Now force of attraction it is experiencing because of what? Because of protons. Because protons present inside the nucleus, they are having which charge? They are having positive charge, and electron is a negatively charged body. Are you able to understand? So let us consider the total charge of this nucleus. Let it be Ze. So what is the total charge? Ze. What is Z here? Number of protons which are present. Neutrons are also present, but neutrons they are neutral, no? So therefore total charge of the nucleus, it is only because of the number of protons which are present. So total charge of the nucleus will be how much? Z into E, and the charge of each electron is only E only. Are you able to understand? Then what is the force of attraction on this electron because of this nucleus? How much? Force of attraction will be F is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. This law we call it as Coulomb's law in electrostatics. No? Are you able to understand? No? So force of attraction between two charged particles, this is the formula. No? And this is the formula to calculate force of attraction between an electron and a nucleus. Are you able to understand? So now let us write Q1 Q2 values. So I will write 1 by 4 pi epsilon naught. What is Q1? Let us call it as a charge of nucleus, and E is nothing but a charge of electron divided by R square. And what is meant by R square? The radius of the nucleus is called as R here, or the distance between the center of this nucleus and the electron is called as R. Are you able to understand? So this is the force of attraction experienced by the electron because of nucleus, because of the protons which are present inside the nucleus. Are you able to understand? Okay. Now, Seema, this is a penultimate shell. No? What is meant by penultimate shell? The shell, the last but one shell, that we call it as the penultimate shell. Clear, no? And inside this shell, there is one more shell. No? Inside that shell, there is one more shell, and in this shell also, electrons will be present. No? Are you able to understand? No? Not only in this shell, electrons will be present in the innermost shell also. Okay. Now, because of these electrons, this electron will experience what kind of force? It will experience a repulsive force. Are you able to understand? Because of the nucleus, this electron experiences attractive force, but because of these electrons, the same electron experiences a negative force, that is, it experiences a repulsive force. Clear, no? So that repulsive force I can indicate by this type of diagram. So this is the repulsive force which is experienced by this electron because of these two electrons. If only two electrons are present in this shell. Are you able to understand? Ma? So because of attractive force, what happens? Ma? Because of attractive force only, this electron is able to move in a circular path. Are you able to understand? In a circular motion already we have studied. No? For any body to move in a circular path, what kind of force is required? Centripetal force is required. Here who is providing the centripetal force? Force of attraction between the nucleus and the electron, that one is providing the centripetal force. Are you able to understand? And because of this centripetal force also, this electron will be rotating very closer to the nucleus. Are you able to understand? Because it is a force of attraction, no? So it will be rotating very closer to the nucleus. Then because of repulsive forces, what should happen? Because of the repulsive forces, this electron, it tries to move slightly away from the nucleus because it is a repulsive force. Are you able to understand? So therefore, what happens to the net force of attraction of the nucleus on this electron? Net force of attraction, will it increase or decrease? నెట్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఏమవుతుంది? నెట్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ decreases. What is the reason? In today only we studied Newton's laws, no? For example, this is a body of mass m. Clear nama? So this is the force of attraction given by the nucleus. But electrons, they will provide some force in opposite direction also. Clear? So therefore what happens to the net force? Net force, what happens? Net force will be F1 minus F2. Clear nama? It means net force definitely reduces. Are you able to understand? So therefore, because of the electrons which are present in the innermost shells, the effect of nucleus on this electron that decreases. Effect of nucleus on the electron will reduce because the force of repulsion between these electrons and these electrons. Are you able to understand, ma? That effect we call it as shielding effect. Okay? And as the number of innermost electrons increases, shielding effect also increases. Clear nama? So here there is one electron, here there is one electron, here there will be one more electron, here there will be one more electron. So many electrons will be present in the innermost shells. No? So all these shells, they form like a screen to the outer electrons. They form like a shield to the outer electrons. Are you able to understand? So that the effect of nucleus on the outermost electrons, that will be reduced. Are you able to understand? So therefore we write a formula. What is the formula? We write Z dash or Z star is equals to Z minus sigma. Are you able to understand, ma? Z star is equals to Z minus sigma. What is meant by Z star here? Z star is nothing but effective nuclear charge. Effective nuclear charge. Clear, ma? Z is called nuclear charge. Clear? And sigma is called what? Sigma is called as screening constant. Are you able to understand? So nuclear charge is because of attraction. Nuclear charge is because of what? Because of attraction existing between the nucleus and the electron. Screening constant is because of what? Screening constant is because of repulsion between the electrons. Clear? Screening constant is because of repulsion. Okay, so here just I am writing the equation like net force relation. So this is force acting on one direction, this is the force acting in opposite direction. So net force you will get only if you subtract both of them. No? Clear number? So force of attraction minus force of repulsion, that will give the net effective nuclear charge which is acting on that particular electron. Okay, ma? So this effective nuclear charge, he may ask you to calculate for any electron. For an electron present in second shell, third shell, fourth shell, దేనికైనా calculate చేయమని వాడు మిమ్మల్ని క్వశ్చన్ అడుగుతాడు. Are you able to understand? He will ask you to calculate the effective nuclear charge on any electron. It may be present in second shell, third shell, fourth shell, any shell. Are you able to understand? So therefore, this concept we can call it as the screening effect or shielding effect. So therefore, what are you able to understand what is happening? So all the electrons which are present in the innermost shells, these shells, they will reduce the effect of nucleus on a particular electron. So that reduced force of attraction, that we call it as effective nuclear charge. Are you able to understand? And what is meant by nuclear charge? Nuclear charge is nothing but the charge of number of protons which is present inside the nucleus. For example, if you take neon, okay, ma? What is the atomic number of neon? Atomic number of neon is 10, no? So nuclear charge of neon is 10 only. Are you able to understand? No? If you take copper, so what is the atomic number of copper? 29. So therefore its nuclear charge is 29 itself. Okay, but its effective nuclear charge is given by Z dash, and it will be definitely less than 29 in terms of copper, and it will be definitely less than 10 in terms of neon. Are you able to understand? Nuclear charge is number of protons, but effective nuclear charge definitely reduced, no? Why? Because of the repulsion existing in the case of electrons. Is it clear, ma? Okay. So make a note up to here. Okay. So therefore, how can I write the definition of screening effect or shielding effect, ma? First you write down, then we will see. Now I will write here. Okay, ma? Because of mutual repulsion between electrons. Okay, ma? The net nuclear charge on an electron is less than actual nuclear actual. Okay, ma'am. Now let us see how to calculate the screening constant on any particular electron. Are you able to understand? So right. Rule number 1 is clear, ma'am? Arrange all the atomic subshells in the form of or in the increasing order of atomic radius. Okay, ma'am? So first of all, we are not writing the subshells in the form according to Aufbau principle. According to Aufbau principle, first 3s comes, 4s comes, then 3d comes. This is called Aufbau principle. No? First we will get 4s, then we will get 3d. But to calculate the screening constant, we have to write them in terms of increasing order of their atomic radius itself. What is the meaning of this one? I will write 1s followed by 2s 2p followed by 3s 3p 3d followed by 4s 4p 4d 4f, like this. So this is the method in which I have to write all the subatomic orbitals. Are you able to understand, or the subshells which are present? So they are written in terms of increasing radius only, no? We are not writing them according to Aufbau principle. Clear, no? This is the first point. Next, so the effect of shielding, on an electron, okay, ma, is only because of the electrons in the left side, and there is no effect of screening because of electrons on the right side. Okay, ma? Can you say what is the meaning of this statement, ma? For example, if I want to calculate a shielding on 3D, I want to calculate a shielding effect on any one electron of this 3D. Are you able to understand? Then what are the elements which are present on the right side and what are the elements which are present on the left side? Electrons. Electrons on the right side, these are the electrons which are present on the right side, no? 4s, 4p, 4d and 4f. So there is no effect of these electrons on 3D. Clear, no? And which are the electrons which are present on the left hand side? 3p, 3s, 2p, 2s and 1s. Only these electrons, they give the effect of shielding. Are you able to understand, ma? So the electrons which are present on the right side, they are not responsible for giving shielding. Electrons which are present only on the left side, they are responsible for giving shielding. Is it clear? Okay. Now see. Now if I want to calculate a shielding on NS or NP, clear, ma? So rules for NS or NP. Okay, ma? So these rules will be always satisfied. So rule number 1 and rule number 2, they are always satisfied, ma? So here I will do one thing, ma? I will name this as rule number 1, I will name this as rule number 2. So first rule is that rule 1 and 2 are satisfied. Okay, ma? Rule number 1 and rule number 2, definitely they are satisfied. What is rule number 1? Arrange them in the increasing order of their atomic radius. Okay, ma? Then the effect of shielding is only because of the electrons which are present on the left hand side. There is no effect of electrons which are present on the right hand side. These two are definitely satisfied. Are you able to understand? Next, second one is because of electrons, or we do one thing, So take the electron on which shielding effect is to be calculated. Shielding effect is to be calculated as reference. Okay ma? So which electron I am taking to be my reference ma? I am taking that electron on which I want to calculate the shielding effect. That electron I will take to be my reference. Are you able to understand? Because that electron cannot provide repulsion because of its own, no? Tanantaku tan repulsion ivvaladu kada. It has to be repelled by only other electrons. Okay? So that electron you take it as the reference. Are you able to understand? Now, because of other electrons, that is better. Because of other electrons in Ns, Np, clear ma? Shielding contribution is 0.35. Are you able to understand ma? Because of other electrons in which shells? In the same Ns shell, Np shell. N means what? N means that electron on which we are trying to calculate the shielding effect. Okay? For example, if I am trying to calculate shielding effect on 3D, then N value will be 3. Okay ma? And in 3D you can find 3p and 3s also, no? Because of those electrons, what will be the contribution to shielding effect, shielding constant? 0.35. Are you able to understand? Exception is helium. There is one exception. Exception is helium, for which the shielding is only 0.30. This is an exception. So in chemistry, exceptions are the most important things. Clear? So we have written a third point. Completed now this side? Okay? Right. Completed up to here. So because of Np and Ns, are you able to understand ma? So what is the contribution? Contribution is 0.35. Or you can just write, instead of Np and Ns, you can write because of other electrons in nth subshell. Just you can write like this also. Nth subshell. Okay ma? Shielding contribution is how much? It is 0.35. And what is the exception? Exception is helium, which can give a shielding of only 0.30. Clear na ma? Then I will write rule number 4. Rule number 4, instead of writing in rule number 4, I will write in rule number 3 only ma. So because of n minus 1 subshell electrons, okay ma, the contribution to the shielding effect is 0.85. Okay? So there will be some electrons in n minus 1 subshells also, no? That is the electrons which are present in the next lowermost shell. So because of them, what is the contribution to the shielding constant? 0.85. Clear ma? And then n minus 2, n minus 3, n minus 4, whatever it may be, all the innermost electrons, they will have a contribution of 1. Clear no? So these are the rules for which electrons? Electrons present in Ns and Np only. Okay? Now I will write rules for clear ma? Nd and Nf. Rules for Nd and Nf. So again same concept. Rule number 1 and rule number 2, definitely they are satisfied here also. Clear ma? So first rule. So rule number 1 and rule number 2, they are definitely satisfied. Okay ma? So what is rule number 1? Arrange all the electrons in the increasing order of their atomic radius. Rule number 2, the electrons which are present only on the left side of a particular electron, they are responsible for shielding, and electrons which are present on the right hand side, they are not responsible for shielding. So that is satisfied here also. Are you able to understand ma? Then rule number 2, for nth electrons, or you can say for remaining nth shell electrons. Nth means nth shell electrons. Nth shell means what? That shell where we are calculating the shielding on D and F. Same shell. Clear, Nama? So what is the screening constant? They will give a contribution of 0.35. Clear? No? And for remaining n minus 1, n minus 2, n minus 3, n minus 4, whatever it may be, they will give a shielding constant of, or they will give a shielding contribution of 1. Okay? So only two rules in the case of D and F, electrons in the D and F subshells. Are you able to understand? For the case of NS and NP, what is one rule we have written? For n minus 1 subshells, for the electrons present in n minus 1, they give a shielding contribution of 0.85. But here n minus 1, n minus 2, n minus 3, n minus 4, all the inner electrons, they will contribute to a shielding constant of 1. So that is the difference between NS, NP, ND and NF. That is the only difference. Remaining everything is same. Are you able to understand? Okay. Make a note up to here. Calculate the screening effect or shielding effect on an electron in 4s subshell and 3d subshells in the case of zinc. Clear number? So what is the atomic number of zinc? Atomic number of zinc is 30. So it means first of all you have to write the electronic configuration, write down the electronic configuration. Clear ma? So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d, 10. Satisfied? So 10, 20, 30. Are you able to understand ma? Now what I am supposed to do, I have to arrange them in the form of increasing order of atomic radius. This is according to Aufbau principle no ma? Aufbau principle prakaram screening effect eskunarante etipothundi anamata. So you are not supposed to calculate the screening effect according to Aufbau principle, according to increasing order of atomic radius. How can you arrange in terms of increasing order of atomic radius? 1s2, 2s2, 2p6, clear ma? 3s2, 3p6, 3d, 10 and finally 4s2. This is the method of writing according to Slater's rules. Okay. First one which I am calculating, first of all I am calculating 4s no ma? So one of the electron which is present in 4s. Clear? So according to this configuration, 4s2, how many electrons are there? 2 electrons are there. But I am calculating a shielding effect on only one electron. No? It means there is one more electron. No? Clear? No? So therefore in nth shell. Now here which is the nth shell? Here nth shell is 4s only. Are you able to understand? And in nth shell, how many extra electrons are present? One extra electron is present. So therefore in nth shell, extra electron is present is 1. And this is 4s, this is NS NP series no ma? NS NP series. So in NS NP series, if an electron is present in the same nth shell, then what is its contribution to the shielding constant? 0.35. So therefore I will write 1 into 0.35. 1 into 0.35, 0.35. That's all. No? So this is the contribution of shielding constant because of another electron which is present in nth shell or 4th subshell. Is it clear? Okay. Now you go to n minus 1th shell. N minus 1th shell. This is my n minus 1th shell, no? So here how many electrons are there? 3 na? Electrons venunaka? So 10, 6 to 18 electrons are there. Clear no ma? So therefore 18 multiplied by, and this is the concept of NS and NP no ma? So what is the contribution of shielding? 0.85. So multiplied by 0.85. So calculate this one. Clear no? Then you go to n minus 2 shell and n minus 3 shell also. Now from here onwards n minus 2, n minus 3, n minus 4, n minus 5, all they will contribute to 1. That's what we have studied. No? They will give a contribution of a shielding constant of 1. So therefore, now what is n minus 2? N minus 2 is the second shell. N minus 3 is third shell. Ashish Vidyarthi, padko unnava, melko. Itla unnavu nu. Clear by n minus 2 shell is second one. N minus 3 shell is first shell. So total how many electrons? 8 plus 2, 10 electrons. Clear nama? So 8 plus 2, 10 electrons. And they will provide a shielding constant of 1. So 10 into 1 is how much? 10. Clear ma? Add all of them. Add all of them. Add chesi answer cheppandi. So therefore total shielding constant is equals to 0.35 plus 18 into 0.85 plus 10. Come on, add them and say the answer. entara 16. So therefore if you add all of them, what is the answer I got? 25.65. Clear nama? Now what is z value in this condition ma? Z value is how much? Nuclear charge is how much? Nuclear charge is nothing but number of protons. Number of protons is nothing but atomic number. Atomic number is 30 minus, this is Z value. So screening constant is how much? 25.61. So therefore how can I calculate effective nuclear charge? Effective nuclear charge is Z star. Clear nama? So it is equals to Z minus sigma. So 30 minus 25.61. So what is the answer? So something around 4.35. 4.35. Clear nama? Are you able to understand? So effective nuclear charge is only 4.35. Clear? But what should have been the actual nuclear charge? If electrons are absent, only one electron is present in 4s, remaining all the electrons if they are absent. Then nuclear charge should be 30, no? But how much minus I am doing? I am having a minus of 25.65. It means the effect of nucleus on the electron in the 4s, it is very less. It is very, very less. Are you able to understand? Because there is a very large force of repulsion between the electrons. So this concept we can call it as shielding effect, or you can call it as screening effect. Actually 30 undali kada? Effective nuclear charge should be how much? 30. Can you final answer enta vachindi meeku? Very less, no? That's it. Clear ma? Now you do the calculation for 3D and say what is your answer. Come on. So therefore what is the sigma value we got? 15.95. So calculate the effective nuclear charge ma? Z star. It is equals to Z minus sigma. So Z value is 30, sigma value is 15.95. So how much? It is 14.05. So this is the effective nuclear charge on an electron present in 3D because of other electrons. Clear nama? So value is how much? 14.05. That is my answer. Are you able to understand ma? That's it. So this is how we will calculate the screening constant or screening effect and the effective nuclear charge because of electrons which are present on the left hand side. Clear? See ma. Generally in a period, if we travel from left to right, what happens to the screening constant? Screening constant increases. Clear nama? So if you travel from where to where, if you travel from left to right, screening constant increases. Okay ma? And effective nuclear charge also increases. Clear ma? Effective nuclear charge means Z star also increases. Clear? Similarly, if we travel down the group from top to bottom, if we travel like this in a group, clear ma? So here also screening constant increases. Clear ma? So screening constant increases across a period also, it increases across a group also. But if I take effective nuclear charge, okay ma, it is almost a constant. Okay ma? In the case of a group, screening constant definitely increases. In addition to screening constant, Z value also increases, no? Z value also increases because in a group, shells are increasing, no? In a group what happens? Shells will continuously increase. So Z value also increases by a large value. So effective nuclear charge almost it remains a constant in a group. But in the case of period, both increases. Screening constant also increases, effective nuclear charge also increases. Are you able to understand ma? That's it. Okay. So remember